Differentiate. 1. Y equals x cubed minus 5x squared plus 6x divided by x minus 2. Well, the denominator is a factor, so it may be necessary to check if we might have the same factor in the numerator so that they can cancel out. So why don't we do that? Yes, it looks like a quotient rule, but we don't have to apply a quotient rule. We could basically factorize or simplify first and then see whether we don't need to apply a quotient rule. So in the numerator, I can see x is a common factor. So I'm going to take that out. Right, so I've taken x out as a common factor. Now I need to factorize the square bracket as well. I can see that minus 2 and minus 3 would help. Minus 2 minus 3x minus 2x minus 3x. Well, so yes, there is a common factor. The x minus 2 in the numerator and x minus 2 in the denominator. And therefore, I'm left with x into bracket x minus 3. Now I could expand this. X squared minus 3x. Now I can find dy dx. Right, finding dy dx, we need to make sure y is in the form of x to the power of n. Then we can apply dy dx. Remember, dy dx is a gradient. Equals n x to the power n minus 1. In this case, here n is 2, we get 2x, and 2 minus 1 is 1, so that's the power of 1, minus this one is n is 1, so you get 1 times 3, so that'll be 3, x to the power 1 minus 1, and that will give 2x. Well, x to the power 0 equals 1. So that's x to the power 0. So x to the power 0 is 1. 1 times minus 3 is minus 3. And that's dy dx. And that's the solution for that. So we didn't even apply a quotient rule. Well, here, it's not a factor. More or less, it's a term. Because it's a term, it might be better to, because they all have common denominator. So we could rewrite this as x cubed over 2x squared plus 4x over 2x squared minus 1 over 2x squared. What that meant is because they all have the same common term, that's why we can do that. And you can see that x squared cancel that. This is x cubed. X squared cancel that, so you got 1 over 2x, because you got 1x left, and you got 2 at the bottom, that's a half x, plus 2 cancel that, so you get 2. X cancel that, so you just get 2 over x minus 1 over 2x squared. And now what we need to do is 1 over 2x plus, that's 1 over x. So that would be 2x to the power minus 1 in indices because there's a 1 here. So that 1 is that. Minus, this one is a half. So there's a half there. That's 1 over x squared. So that would be x to the power minus 2. That 2 is that one here. So that's how we write that in indices. Now we can find dy dx. Again, dy dx is a gradient. What that meant is you can see it's in that form now. X to the power n. N is 1 here. N is minus 1. And n is minus 2. So that's 1 there. So 1 times a half is a half. X to the power 1 minus 1 is 0. Remember, you always go down in power when you differentiate. plus minus 1 times 2 is minus 2, right? And then x to the power minus 1 is minus 2. Again, plus, well, actually that's minus, but minus 2 times minus a half is plus 2 over 2, because that's 2 times a half, that would be 2 over 2. That's plus. This eventually will be minus, and that will be x to the power minus 2 minus 1. Minus 2 minus 1 is minus 3. And that will be x to the power 0 is 1. 1 times a half is a half. Well, minus plus minus 2 is basically minus 2 over, now minus 2 over x squared, right? So I'll just put it back to normal because that's x to the power minus 2. Just to remember, the relationship between negative power and positive power is inverse. 1 over x to the power minus 2 will be x to the power 2. You just swap them. You can see here now, that goes there and that goes there. So it's just swapping. And this one here will be plus 2 over 2 is 1. And then you get 1 over x to the power 3. So that's indices being applied there. And that's the answer. So that's the y dx. And that's the final answer.